Hello and welcome back. In this video we'll start Chapter 3, specifically Section 1, and this is all about graphing quadratic functions. So when we look at a quadratic function, this is a function whose output is going to be solved according to a quadratic polynomial. So we've got ax squared plus bx plus c. And essentially, because we've got this x squared term in here, this is not going to be a straight line anymore. If it was just bx plus c, that's going to be a straight line. It's a linear function. But since we have this x squared term, we're going to get this curve in here. And there's a couple of important features of a parabola, as this is called. One of which is going to be this bottom point here, which is called the vertex. And if we draw a straight line through the vertex going straight up, what we'll have is mirror symmetry. So this line here is going to be the line of symmetry. If I could draw perfectly well, this would be exactly symmetrical on either side of the line. And one thing that you'll notice is that this parabola is pointing upward, as in it opens upward, as if this was a mouth, the mouth would be facing up. And this happens when a is going to be greater than 0. One reason why this is true is if x is going to be a big number, if I look at, say 10, if I look at the difference between 10 squared and 10, 10 squared is much bigger than 10. So this first term is what makes the parabola open up, since if we get to really big x values, they're going to be positive, so they're going to be above the line. Whereas if I look at a function, the same sort of function, just a quadratic polynomial, and if a is less than 0, when x gets really big, this term is going to be very negative. So we're going to be going down. So in any case, when a is positive, the parabola opens up. When a is negative, the parabola opens down. We still have a vertex, and we still have our line of symmetry. So when we look at this as well, we can see that when the parabola opens up, this vertex is going to be the lowest point. So this is in fact going to be a minimum of the whole function. This is going to be the smallest point. Whereas if the parabola opens downward when a is negative, that vertex is actually going to be the highest point, which will be the maximum. So all of these are very nice features. So it turns out that there's a very nice way of writing a function down, and that's called standard form. And the standard form for a quadratic function is going to look something like this. So to explain why, if we think about just sort of a regular parabola where we've got a times x squared, where a is going to be positive. Since a is positive, this will be opening upward. And the vertex here is just going to be at 0, 0. The line of symmetry is going to be x equals 0. And this is nice and symmetrical. However, we saw before that we can shift things horizontally by subtracting or adding something directly from x, and then if we add something to the entire function, we're going to shift it vertically. So what we've done is we've shifted this to the right, h, and upwards, k. So this vertex is now going to be at h, k. So when we write the equation for a parabola in this form, we can read off the vertex really easily. It's going to be hk, where it's x minus h squared, and then the whole thing will be plus k. The line of symmetry, if we go straight up and down through that point, this is going to be when x is equal to h. We see that all of these points are just h over to the right, and every height. So we can do the same thing if a is negative. It's just instead of opening upward, we're opening down. So here again, we have our vertex for our standard function with when a is 0. So this vertex would be 0, 0. And the line of symmetry, if I could draw straight, is going to be at x is equal to 0. Whereas over here, I've shifted this to the right h and then up k. So to the right h, up k. That means that this point is kh. And the line of symmetry should be passing right through the vertex. Let's pretend that it does. That line will be x is equal to h. So if we want to graph any quadratic function that's in standard form, it's fairly easy. So again, let me do this in a different color so it stands out. Here is standard form. Instead of writing ax squared plus bx plus c, if it's written in this way, we can read off whether or not the parabola opens up or down, depending on if a is positive or if a is negative. And the vertex is just going to be hk. And this information will allow us to graph a quadratic function rather easily. So what are the ingredients to graphing a function that's in standard form? Well, the first thing to notice would be whether or not we should be drawing the parabola up or down. So again, up means that the function is going up on either side, whereas opening down means that the function is going down on either side. We also need to determine where the vertex is. So where the minimum is, or where the maximum is. We'll find any x-intercepts and y-intercepts. This just gives us a few points that we can then connect the dots. So that's all there is to it. The x-intercepts are where the height is 0, and the height of the function is f of x. So all we're doing is we're solving this equation. Now, I'll do a couple of examples, and there may not be any x-intercepts. There could be one x-intercept, or there could be two. And I'll draw some pictures to show you why. And then the y-intercepts, that's when x is 0. That means we're right along that y-axis going up and down. So we just plug in 0 for x and we solve it. So let's do an example. We have the graph, we want to graph f of x is equal to negative x minus 1 squared plus 4. So first and foremost, the first thing that we want to do is we want to look at the sign of what's multiplying the x minus h squared. So here, a is going to be negative 1. So the parabola opens down. So step 1 done. Step 2, we should look to see where that vertex is going to be. So we know the vertex is going to be at hk. So h here is going to be 1 because it's x minus h. So even though it's negative 1, it's x minus h. So h is just going to be 1. Whereas k is going to be 4. So the vertex will be at 1, 4. So if we just draw a rough sketch of what this looks like for the moment, we know that at 1, 4, this is where the vertex is, and it opens downward. So it's going to look something like this. Now, this isn't precise because I haven't figured out where is the y-intercept or where are the x-intercepts. So next we just need to know what are the x and y intercepts, and then we can start connecting the dots. So let's do the x-intercepts first. If my picture is accurate, we should have 2 of them. So for the x-intercepts, I want to see where is the height equal to 0. So So I want 0 is equal to negative x minus 1 squared plus 4. There are multiple ways of solving this, but I am going to subtract 4 from both sides. So we'll have negative 4 is equal to negative x minus 1 squared. I will divide both sides by negative 1 to get 4 is equal to x minus 1 quantity squared. So here I know that x minus 1 squared has got to be equal to 4. So x minus 1 is either going to be the positive square root of 4 or the negative square root of 4. So we have two solutions, just like we expected. So x minus 1 is either going to be the square root of 4, or x minus 1 is going to be negative square root of 4. Square root of 4 is 2. So if I square 2, I get 4. If I square negative 2, I get 4. So x is going to be, if I add 1 to both sides, either 3, or if I add 1 to both sides, this will be negative 1. So I now know that x is going to be 3 or negative 1. So this point right here should have the x value of 3. This point right there should have the x value negative 1. And then let's find the y value, so the y-intercept. So if I plug in 0 for x, I'm going to get negative 0 minus 1 quantity squared plus 4. So 0 minus 1 is negative 1. Negative 1 times negative 1 is 1. And negative 1 plus 4 is 3. So this is my y-intercept. And these are my x-intercepts. So let's draw the picture. We've got right up our coordinates. 1, 2, 3, 4. Our vertex was at 1, 4. Our y-intercept is at 3, so along the y-axis we go up to 3. Our x-intercepts were at 3 and negative 1, so we come over to x is equal to 3 and x is equal to negative 1, and we have enough points to be able to draw our parabola if I could draw very well. So again, we've got the vertex, which happens to be a maximum, the y-intercept, and a couple of x-intercepts. Perfect. Let's do one more quick example. Let's graph f of x is equal to x minus 2 squared plus 1. So right away, we see that our a, which is going to be the number multiplying this, a is going to be equal to 1. So we are going to open upwards. If we look to see our vertex, we have x minus 2 plus 1. So h is going to be 2, k is going to be equal to 1, so our vertex is going to be 2, 1. So if I draw a rough picture to start with, we'll be at 2, 1, and we're going to open upward. And we can see that we shouldn't get any x-intercepts. And to briefly show why, if I do try to solve 0 is equal to x squared minus 2 squared plus 1, if I move the 1 to the other side, I'm going to get minus 1 is going to be equal to x minus 2 squared, and then that means that x minus 2 is going to be equal to the square root of negative 1, or x minus 2 is going to be equal to the negative square root of negative 1. But these are imaginary. This is I, and this is minus I. So no intercepts, no x-intercepts. The y-intercept is just when we plug in 0. So this is going to be 0 minus 2 squared plus 1. So this is negative 2 squared is 4, plus 1 is 5. And we now have enough to graph our parabola. 1, 2, 3, 4, 5. 1, 2.